All right, welcome back to another edition of the pre-recorded physics class. This is for our Thursday, Friday classes, the 16th and 17th of April. So today we want to have already watched the Edpuzzle drag force before you watch this class today, this pre-recorded class, otherwise it won't make much sense. I want to introduce you basically, after going over the schedule, I just want to introduce you to the drag force lab and kind of show you that on Canvas and help you get started there. Remember that there's no WebAssign this week. That time that you spend on WebAssign should be instead spent on this lab. Okay, it's a time intensive lab. It counts as a double lab, 40 points. Next week, we look to resume our normal live class. Okay, so Monday, Wednesday, and Tuesday, Thursday. Remember to record, if you haven't already, a video of an object sliding to a stop. You should have that done by class time on Monday or Tuesday. And then during the week, next week, we'll be doing a coefficient of friction quiz that uses this video that you've done. All right, so here's a snapshot, screenshot of the Edpuzzle about drag force. We spoke briefly about drag force last class. Here we go a little bit more into detail. So it's important to have this conceptual understanding, right, before you go into the drag force lab for today. So make sure that you've watched the Edpuzzle before you watch this one. All right, let's talk about the lab for today. So again, you'll be navigating through Canvas, the home screen, right, our grid. You'll be looking right there. You see a hyperlink. And basically what you get to learn is you get to learn to unleash some new Excel powers, right? You've gotten really good at using Excel to graph data, right? Put it in a data table and graph it, get linear fits and so on. We're going to use Excel, even though we're going to create graphs again this time, we're going to use a whole new side of Excel where you get to tell Excel to do a bunch of calculations, okay? And this is another opportunity, even though it's in the context of physics, I can almost guarantee that every one of you in some capacity will do at a later time, not in physics, right? Could be economics, could be housekeeping, could be accounting, could be wherever, engineering. You're going to do this spreadsheet skill that you're going to learn, or these series of spreadsheet skills that you're learning in this lab. You will do them again, I guarantee you. I can almost guarantee you, no matter what profession you go in. So it's a nice transferable skill. Obviously, we're going to keep a physics topic, but what you learn will apply to a lot of different areas in the future. So you've learned already from the drag force, right? If you've watched the Edpuzzle and you remember last class, that the motion of an object in the presence of the drag force creates a non-constant acceleration, okay? Because the drag force is constantly changing because it's velocity dependent. Typically, non-constant acceleration means we need to resort to calculus. But the power of a spreadsheet gives us a way to work around this. So what we can do is we can take non-constant accelerated motion and we can break it down into a bunch of little problems over like a very small time interval, like maybe a tenth of a second or even a hundredth of a second. And over that hundredth of a second, the acceleration doesn't change very much. So we can do a constant accelerated motion over like a tiny time period. And then we can change the acceleration, right? And then the next time period, we'll recalculate. And then we'll change the acceleration again a little bit, and then we'll recalculate, and so on. Now, if you were to do that by hand, that would be ridiculous, right? You'd be sitting there for hours and hours and hours. But the spreadsheet can do all of that automatically, right? All you have to do is tell Excel, tell the spreadsheet one time how to do it, and then you can just copy that math equation downwards. It's really, really cool. So we're going to be following directions on Canvas assignment. So I'm going to go to Canvas now, right? I'm going to click on this link and get you acquainted with how things are looking right there. So again, let me, this is already the link. So I'm going to click on it again. Right here, you see the directions. So this is very much number one, do step one. Number two, do step two. Number three, do step three. So it's you have to be very sequential and just follow the steps in the lab. You don't really need me, honestly. That's the nice thing about this. So me not being around doesn't really hinder you at all. You're going to end up turning two things into this lab here, right? Right here's the submit assignment. You're going to print out the last 2 pages of the lab. You're going to handwrite your answers and then scan it in as a picture or a PDF. And then you're also going to upload this file of Excel that you end up doing. Okay. So very late in the, very late in the lab. Okay. One of the last things is you have to put multiple trend lines on one graph. So that's also another graphing skill. I've created a separate video for that. You don't have to worry about this till the very end. Remember that this is a double lab, right? So it's 40 points. I've already created the rubric for you, so you can kind of, before you turn things in, right, you can sort of read the rubric here and make sure that you are checked off. Right now I have this lab due 2 Fridays from now. Okay, so a little bit over a week. All right, let's take a look here at the link for the actual instructions. Clicked on that, PDF, download. Maybe make it a little bigger for you guys. It's not getting bigger. There we go. Okay, so here's brief discussion. Okay. Here are the equations we're going to use, right? So if you remember from the DragForce lab, that we can model, it looks slightly different. It just said BV to the N. So remember I said that N could vary. So we're going to model objects falling through the air, and we're going to just assume that it's proportional to V squared. So notice that we made N equals 2 for our model here. So these are all equations that you're familiar with, right? So this is the weight equation, right? You know that. Here's a trusty old kinematics equation way back when. Here's Newton's second law. Can't get anywhere in Newtonian physics without that, right? And then here's our new drag force equation. So we're going to be using all 4 of these. We're going to be learning how to write them in Excel. Okay. So as you see here, some things you do on paper. I did design for this to be done on paper, but you're only turning in the last 2 pages. So it doesn't really, honestly, it doesn't really matter how you do this piece here, whether you do that on paper or you print it out. But right here, setting up the spreadsheet, this is where you want to really be careful and start going step by step. It tells you exactly how to do this. I would recommend, okay, that by class time on Monday, you try to get to step 18, okay, where there's a first chance to get a sign off. Step 18. I would estimate that it takes you 1 to 2 hours, depending on your previous familiarity with Excel, doing this new skill. It'll take you 1 to 2 hours to get here. Okay, probably more on the 2-hour side, to be honest. But then the rest of this, because you're gonna copy and paste so much, you're gonna basically exponentially grow the size of your Excel sheet in a fraction of the time, right? So maybe getting to step 18 takes 2 hours, but then doing some of this other stuff where you go from 1 to 10 graphs is only going to take you like another hour. So, but it does take considerable time. Okay. So you really need to put some time in now, today, and over the weekend. Try to get to step 18 by Monday. All right. Good luck, and we'll see you in class again on Monday.